Three cases for Doppler effect in sound waves. Case 1. Source S is moving with velocity Vs and observer O is stationary. Then in this case, apparent frequency nu dash will be equal to the original frequency nu into V by V minus Vs. In case 2, if source S is stationary and observer O is moving with velocity V0. In that case, apparent frequency will be equal to nu into V minus Vo by V. And case 3, if source is moving with velocity Vs and observer is also moving with velocity V0. In that case, apparent frequency will be equal to nu V minus Vo by V minus Vs. Now we have to derive these relations. Case first, source is moving and observer is stationary. Source S is moving with velocity Vs towards the observer. And let at time t equal to 0, the distance between the source and the observer is L. The speed of the sound emitted by the source is V, which travel from source to observer. So reference directions in the direction of sound velocity will be positive, and in opposite direction it will be negative. Therefore, at time t equal to 0, the source emits a wave crest and it reaches at the observer at the time t1, and this t1 as per the definition of speed equal to distance by time will be given as distance, which is L at t equal to 0, and velocity of the sound is V. This is the equation number 1. This source is moving with velocity Vs, and after a time t0, this is the time period, it emits another crest, and in meantime the source travel a distance Vs into t0 and reaches the point V if initially the point is A. Now the distance remaining is L minus Vs into t0, and the time taken by the wave to reach the observer will be distance, this is L minus Vs into t0 divided by velocity of the sound V plus t0, because this is the time after which the second crest is emitted. This is equation number 2. Similarly, if we write the time taken by the n plus 1th wave crest to reach the observer, it will be L minus n into Vs into t0 by V plus n into t0. This is equation number 3. Therefore, Tn plus 1 minus T1 will be equal to, it is L minus n Vs T0 by V plus n T0 minus L by V. This is equal to L by V minus n Vs T0 by V plus n T0 minus L by V. This L by V get cancelled, and rest is n T0 minus n Vs T0 by V. This period Tn plus 1 minus T1, this is the time period of the n wave which is observed by the observer, and this time period is T, which is the apparent time period. So we can write time period will be equal to Tn plus 1 minus T1 by n, that is equal to n T0 minus n Vs T0 by V divided by n, or we can write it as T0 minus Vs into T0 by V. Hence T will be equal to T0 1 minus Vs by V. 1 by T that is equal to 1 by T0 and 1 by 1 minus Vs by V. Inverse of the time period is the frequency. So we can write this implies that apparent frequency nu dash is equal to 1 by T0, this is the frequency, divided by 1 minus Vs by V. Or it can also be written as nu into V by V minus Vs, which is the relation which we have to derive. Similarly, we can find the apparent frequency in case of source is stationary and observer is moving. Next case is source is stationary and observer is moving. Suppose source S, which is stationary and is at a distance L from the observer, and observer is moving with velocity v naught towards the source. At t equal to 0, this source generates a wave crest, and this wave crest reaches at the observer at time t1, that is given with the formula speed equal to distance by time. Distance is L and speed will be equal to, because effectively v is the speed of the sound from source to observer, and observer is moving with speed v naught. So effective speed of the sound will be v plus v naught. So T1 will be equal to L by V plus V naught. This is the equation number 1. Then after interval T naught, which is the time period of the wave crest, next wave crest is generated by the source, and this is received at the time T2 by the observer, and this T2 is given by, it is L minus, because now the distance between the source and observer will be, in time t0, distance covered by the observer will be v naught t naught. So effective distance between the source and observer will be L minus v naught t naught, and this distance is covered by the effective speed v plus v0 and the interval t naught. This is the equation number 2. Similarly, n plus 1th wave crest will be received by the observer at the time given by L minus n v0 t0 by v plus v0 plus n t0. This is the equation number 3. Therefore, Tn plus 1 minus t1, if we subtract the equation 1 from 3, we will have L minus n v0 t0 by v plus v0 plus n t0 minus L by v plus v0. This is equal to, here this L by v plus v0, if we separate it, minus n v0 t0 by v plus v0 plus n t0 minus L by v plus v0. This L by v plus v0 get cancelled, and remaining is n t0 minus n v0 t0 by v plus v0. And so time period of the wave observed by the observer will be Tn plus 1 minus T1 by n. This is equal to n into T0 minus V0 T0 by V plus V0 divided by n, and n get cancelled, and it is equal to T0 minus V0 T0 by V plus V0. Hence, T will be equal to, taking the T0 common, remaining is 1 minus V0 by V plus V0, that will be equal to T0, LCM is V plus V0, and remaining is V plus V0 minus V0, V0 and V0 get cancelled, so it is T0 into V by V plus V0. Inverting, 1 by T will be equal to 1 by T0 into V plus V0 by V, and inverse of the time period is frequency, so the apparent frequency will be equal to frequency into V plus V0 by V. Case third, source is moving and observer is also moving. That means it is the combination of the first two cases. This source S is moving with velocity Vs and observer is moving with velocity Vo. And sound has a velocity V from source to observer. Now considering the two cases and then combining them, we will have, if we consider that source is moving, in that case the apparent frequency observed by the observer will be equal to nu, this is the natural frequency of the source, into V minus, considering observer is stationary, then it is V by V minus Vs. Now considering the observer is moving also, for the frequency nu1 dash, then nu dash will be equal to, this is the final apparent frequency, it will be equal to nu1 dash into V minus Vo, and considering the source now stationary. So effectively we will have nu dash equal to, replacing this nu1 dash, we will have nu V by V minus Vs into V minus Vo by V. This V and V get cancelled, and finally we will have nu dash equal to nu V minus Vo by V minus Vs. This is the apparent frequency if both the source and observers are moving.